Welcome back to our chemistry flipped classroom. And today we're talking about how to predict the results of a particular kind of reaction. And so we're going to be taking what we already know about writing formulas and about writing equations, and we're going to be applying it to a specific kind of reaction. And that reaction is called a precipitation reaction. So our goals for today are to be able to predict the solid that forms in a precipitation reaction, to be able to predict the results of the reaction. And then over the next couple of days, we're going to be able to predict what the solid is going to be of the two compounds. We're going to learn to write three different kinds of equations: molecular equations, ionic equations, and net ionic equations. So first, just a quick refresher, some of the common results of a reaction would be the formation of a solid, the formation of water, the formation of a gas, or the transfer of electrons. So today we're specifically going to be talking about the type of reaction that results in the formation of a solid. So we'll be combining two different aqueous solutions, so two different compounds dissolved in water, and we're going to be producing a solid. But before we can jump into that, we really need to think about what it means when an ionic compound dissolves in water. So when an ionic compound dissolves in water, so let's take sodium chloride as an example, because that's a really familiar ionic compound for us. When we put it into water, it actually dissociates. We write this as solid NaCl, and water forms aqueous NaCl. Does that mean that the NaCl stays together as little NaCl compounds? Does it mean that we have atoms of sodium and chlorine in the water? I hope not, because sodium and water are a bad combination. Or does it mean that we have sodium ions and chloride ions dissolved in the water? That's what it really means. When we put an ionic compound into water, if it dissolves, it does something called dissociating. So you know that to associate means to come together. Dissociating means to come apart. So when an ionic compound dissolves in water, the ions separate from each other and they move around independently. This makes ionic compounds what we call strong electrolytes. So when we put an ionic compound into water, it actually allows the water to conduct electricity. Pure water does not do that. So when we have an ionic compound dissolved in water, we don't actually have an ionic compound anymore. We have a whole bunch of loose dissociated ions floating around in the water. So when we have a reaction where a solid is formed from a solution, we call that a precipitation reaction, because the solid precipitates out, meaning that it forms that solid and it falls right out of solution. So we talk about the solid as the precipitate, and we will also use the term insoluble, meaning not soluble, to describe these solids. When our positive and our negative ions come together to form a precipitate, just like any other ionic compound, the net charge of that precipitate has to be 0. So if we look at our example here, we have lead 2 nitrate, a solution of lead 2 nitrate reacting with a solution of potassium iodide. And that's going to give us the formation of a precipitate, the lead 2 iodide, and an aqueous solution of potassium nitrate. So the potassium ions and the nitrate ions are still both just floating around free in the water. But those lead ions, as soon as they see the iodide ions, they grab on and they form a solid and it precipitates out. Stalactites are a great example of this kind of a reaction. We have aqueous calcium hydrogen carbonate, and the calcium carbonate, which is what the mineral that makes up the stalactites, precipitates out, leaving behind water and carbon dioxide gas. So if we have 2 ionic compounds dissolved in water now, not just the one, but 2, if we have potassium chromate and we have barium nitrate, what products are they going to make? So first thing we're going to do is we're going to separate out all of these soluble ionic compounds. And we know they're soluble because they say AQ here. They're dissolved in water. So we don't really have potassium chromate stuck together. We have two potassium ions and we have a chromate ion. Now notice that when I've separated this out, I've pulled the two in front of the potassium because this is not one potassium ion that is two potassium ions stuck together. It is two individual potassium ions floating around in the water. On the other hand, I've left the chromate all stuck together because this is covalently bonded together. It was ionically bonded to two different potassium ions, but this is all covalently bonded together, so we're going to leave it put together. So whenever we dissociate, we want to make sure that we leave our polyatomic ions put together, but we dissociate ions from other ions. So same thing here. We have the barium ion here, the Ba2 plus ion, and we have two nitrate ions because one barium ion was bonded ionically to two nitrate ions. Now, those two nitrate ions, each nitrate ion is still bonded together covalently, one nitrogen and three oxygens, but I have two separate ions. And so that's why we pull this two out front. Now, how do we decide what our products are going to be? Well, in our example, we had potassium chromate and barium nitrate, which means that we have potassium ions and barium ions. If the potassium combines with the nitrate, we have potassium nitrate. If the potassium combines with chromate, we have potassium chromate. Barium can combine with nitrate, give us barium nitrate, or it can combine with chromate and give us barium chromate. So in this case, if we wind up with potassium chromate and barium nitrate, we're just back where we started. So we know that they're going to switch partners. We're going to have potassium nitrate and barium chromate. How do we know if anything happens? Well, we can see from our reaction that we do get the formation of a solid. Now, you guys would need some more information than what you already have. As a chemist, I know that barium chromate is a yellow solid and potassium nitrate is a white solid. I also know a little bit about solubility rules. So I would predict that barium chromate is the solid that would form. So we're going to spend a bunch of time in the next couple of days building our solubility rules and learning our solubility rules so that not only will you be able to predict what the two potential products are, but you'll actually be able to predict which one of those will be the precipitant. So let's just practice this partner swap that we've just learned about, okay? So we have three different reactions here, and we're going to practice figuring out what the potential products are going to be. So just remember that the cation is going to switch anionic partners with the other cation. So in this case, our sodium is going to take our calcium's partner, and our calcium is going to take our sodium's partner. Now remember, we always need to write neutral compounds. So the first thing we're going to do is we're going to write that this is going to be sodium chloride. Notice I did not keep that little subscript 2 because sodium's a +1, chloride's a -1. So I don't need any subscripts. That product is neutral. And calcium and hydroxide. Now the hydroxide ion is only -1. The calcium ion is +2. So I need 2 whole hydroxide ions. Now, to balance this equation, I notice that I have 2 chlorides here and only 1 here. I have 2 hydroxides here and only 1 there. So I'm going to put a 2 in front of the sodium hydroxide to give me 2 hydroxides to balance these 2 hydroxides. And whoops, I'm also going to put a 2 in front of the sodium chloride. Sorry, I left that out. 2 in front of the sodium chloride so that I have 2 sodiums and 2 chloride ions. All right, let's move on to the next one. So we have copper 2 bromide and ammonium carbonate. So our copper and our ammonium are going to switch partners. Notice that I'm not putting the positive ion with the positive ion, but I'm putting the positive ion with the negative ion and the positive ion with the negative ion. So this gives me copper 2 carbonate, and I don't need any subscripts because that's a +2 and a -2. and ammonium bromide. And again, I don't need any additional subscripts because ammonium's a +1 and bromide is a -1. On the other hand, I had 2 ammoniums over here and 2 bromides over here. So I'm going to put a 2 in front of my ammonium bromide to make that balanced. Last one more time, the cations are going to switch places. So we're going to have potassium nitrate and iron 3 sulfate. Now this one requires some thinking. We needed to look here and realize that because the iron is with 3 nitrates and each nitrate is a -1, that the iron must be a +3. So the iron is still going to be a +3 on this side, which means that I'm going to need 3 sulfates and 2 irons in order to have a neutral compound. Now, because of that, I'm going to put a 3 in front of my potassium sulfate over here so that I can balance the 3 sulfates on the product side. I'm going to put a 2 in front of the iron 3 nitrate so that I have 2 irons to balance the 2 irons on the product side. And that has now given me 6 nitrate ions and 6 potassium ions. And so I need to put a 6 in front of the potassium nitrate on the product side. All right, that's it for writing precipitation reactions. We're going to talk tomorrow about how we know which one of our products or both of our products are solids and what to do if neither of them is a solid. So as always, if you have any questions, let me know, and I look forward to seeing you in class tomorrow.